To discuss some problems on normal distribution. Okay, let us go to the first problem here. The lifetime in hours of a certain electrical equipment has normal distribution with mean 80 and standard deviation 16. So here it is given that the lifetime of a certain electrical equipment has normal distribution. You need to find out what is the probability that the equipment lasts for at least 100 hours. So as you know, in the previous section we have discussed that we are going to deal with three distributions like binomial, Poisson and normal distribution. It is clearly given that always we indicate the variables with capital letters. Let x be the random variable indicating the lifetime of electrical equipment. So it is given that x is normally distributed. For normal distribution, we write in this way: x follows normal distribution. Its parameters are nothing but mean, mu and variance sigma square. So here x is normally distributed, given mean means mu is 80 given here, standard deviation is 16. So it follows normal distribution with mean 80 comma variance means square of standard deviation is called variance. So it is the given part to you. What to calculate here? Find the probability that the equipment lasts for at least 100 hours. You need to find out the probability that the lifetime of the equipment is at least 100 hours. What do you mean by the word at least? Generally we come across two words called in probability, at least or at most. At least means that given value or more. You should get at least 40 marks means in the examination it means that you should get either 40 or more than that. Similarly, if the lifetime should last for at least 100 hours means you need to find out, as x is the lifetime of the equipment, you need to find out the probability x greater than or equal to greater than 100. So I said to you that to do the problems on normal distribution, we are going to make use of standard normal variate. So what is standard normal variate? Standard normal, for every normal variable you can define a standard normal variate, which is indicated with z, defined as x minus mu by sigma. So to find out this probability, this x should be converted into z, which is called the standard normal variate. Then how can you convert this x into z? You need to subtract with mu and you need to divide with sigma, means x minus mu by sigma. You cannot do only on the LHS, you should do the same on the RHS also. Okay, so as x minus mu by sigma is z, we write that with sigma greater than 100 minus what is mu here? In the given problem, mu is 100, sigma is 60. So you need to find out the probability that x greater than x greater than x greater than 100 minus 80 means 20 by 16, which is nothing but probability of z greater than 20 by 60 is nothing but 5 by 4. Let us convert that into decimals, which is nothing but 5 by 4 is nothing but you will get 1.25. You need to find out the probability that z greater than 1.25. So to find out in the those who have already watched in the previous video, I think I have skipped the step here. I wrote the value directly because I didn't mention how to get those values. In this video I am going to give the clarity how to calculate these values. These values are obtained from the areas of standard normal distribution. Areas of standard normal distribution. So in the previous video I said that it is a symmetric curve. Always this is about z is equal to 0. The area on the left tail is same as the area on the right tail. So if you want to, you need to find out the value. Let us say that we have 1.25 here. Z greater than 1.25 means you need to find out this value. From here, this part you need to calculate. To calculate this value, okay, what you need to do is nothing but to calculate the shaded part from this entire left tail. Okay, you better subtract from this entire left tail, right tail. If you can subtract this part, you will get this area. Am I right? From the figure, you need to find out the value. Z greater than 1.25 means you need to calculate this value. To calculate this value, what you need to do is nothing but from the entire right tail, okay, subtract this part so that you will get the required one. Means probability of Z greater than 1.25 can be calculated as probability of at Z greater than 0 minus probability of 0 less than Z less than 1.25. Means this and as the entire probability is 1, always the entire area is 1. As these two are two equal parts, the entire left tail is 0.5, entire right tail is 0.5, means 0.5 minus probability of 0 less than . So to calculate the value between 0 to 1.25, you should refer to the areas of standard normal distributions, which the graphical representation will be given in some of the textbooks. I will send you the picture of that also. Now meanwhile I will tell you how to calculate those values from the textbook. So this part you can carry for your examination. You need to find out probability of 0 less than Z less than 1.25. Means here Z, here you have Z, here you have another Z. You need to find out the area between 0 to 1.25. Just you look, 1.25 is a sum of 1.2 and 0.5, which is nothing but 0.3944. Again I am repeating, to find out the area between 0 and 1.25. So it's 1.25 is a sum of 1.2 and 0.5. Here you find out the value in the intersection of these two, which is nothing but 0.3944. So this is nothing but 0.5 minus 0.3944, which is nothing but 0.1056. So the required probability is this. The probability that the lifetime of the equipment is more than 100 hours is 0.1056. Let us do similar problem here. With this we can finish the normal distribution problems. Okay. On normal distribution, the mean and standard deviation of wages of 6,000 workers in a factory are rupees 1200 and rupees 400 respectively. Assuming normal distribution, okay, two bits are given to you. Percentage of workers getting wages above 1600 and number of workers getting wages between 600 and 9000. So here it is given that the wages of workers in a factory is normally distributed with mean salary to rupees 1200 and standard deviation 400. So it is given that x, you need to consider x as the variable indicating the wages of workers in that factory, and it is given that assuming normal means, I think you know that you should write x follows normal with mean mu comma variance sigma square. What is mean salary is given here? 1200. What is its standard deviation? Standard deviation is sigma, which is nothing but 400. So it is the given data. Then two bits are given to calculate. The first bit here to calculate is nothing but percentage of workers getting wages above 600. So you need to find out the number of workers or the percentage. So percentage and number, if you can calculate the number of workers, you can do the percentage usually. So let us go to the first bit. For that, if you observe the difference with the previous one, in the previous problem we have obtained the areas from the textbooks part, but here in some parts, in some questions, the areas will be given to you. So the corresponding area values are supplied to you. So you need to calculate the percentage of workers whose salary is more than 1600. Means you need to find out probability that x greater than 1600. So I said you that whenever we have x on the normal distribution, you should convert that into z. So how do you define z? Z is nothing but x minus mu by sigma, where z is a standard normal variate. The areas can be calculated from the given table or from the areas of the standard normal distribution. So x minus mu is greater than, I said you that you should do the same operation on the left. If you are making the minus mu here, you should do the same on the RHS, that is 1600 minus mu. If you are dividing here, you should divide here also, which is nothing but z greater than, what is mu here? Mu, the mean salary is given as 1200 and with a standard deviation of 400. Probability of z greater than 400 by 400, which is nothing but probability of z greater than 1. So to calculate these values, I said you that you should draw a graph, okay, which indicates that this is the z middle value for z, which is nothing but 0. So I said you that the entire value area is 1 here. On the left hand tail is, it is 0.5, and on the right hand tail is also 0.5. You need to find out the value probability of z. If you consider z here, you need to find out this value, means z greater than 1. So for that, the similar steps, you need to, from the entire right tail, you need to subtract this part. So if you, from the entire right tail, if you subtract this part, you will get the shaded one. So probability of z greater than 1 can be calculated as, this entire part is 0.5 minus probability of 0 less than z less than 0.5, means 0.5 minus, what is the area in the table itself given? Probability of 0 to 0.5, it is given as 0 to 1, it is given as 0.3413. Okay, so got it girls? You need to find out the value x greater than 1. For that, from the entire right tail part, you subtract this part, then you will get this, means entire 0.5 means 5 to 0.5 minus probability of 0 less than z less than 1. From the given areas, it is around 0.3413, which is nothing but 0.1587. So how do you calculate the percentage for this? Percentage for this we will calculate that as 0.1587 into 100, which is nothing but approximately 15% of the workers who are getting wages above 1600. So let us do the second bit also. What is the second bit? You need to find out the number of workers getting salary between 600 and 900. So you need to find out P of x less than 600 less than x less than 900. Again you need to do the same operation. You cannot do anything with x. You should convert that into z by subtracting with mu and dividing with sigma. So the same should be done on the LHS and RHS. So what is mu here? The mean salary is nothing but 1200 by the standard deviation is 400 less than z. less than 900 minus 1200 by 400. So which is nothing but minus 600 by 400 less than Z less than minus 300 by. So we have cancelled the hundreds here. So we got probability of minus 6 by 4 less than Z less than minus 3 by 4. Okay. Minus 6 by 4 means we have minus on the here and here. So to take out these minus, let us multiply minus here and here so that these two inequalities are going to change. This is a mathematical transformation. Whenever we change the signs in inequality, okay, then these are going to, the places are going to exchange. So actually this value is nothing but minus 1.5 less than Z less than minus 1.75. If you want to remove these minus, okay, on the left hand side as well as right hand side, I think the inequality will be reversed. That will be minus will be absorbed and you will get 1.75 here. This is a mathematical transformation. 1.75 less than Z less than 1.5. So to calculate these values, this is nothing but 0. Z less than 1.5 minus probability of 0 less than Z less than 0.75. In the given question itself, the areas are given to you. Area between 0 to 1.5 is nothing but 0 to 1.5 is nothing but 4.3322 and 0.75 is nothing but 0.2732. So this is nothing but in the given question itself the areas are supplied to you. No need to refer to the table. The area between 0 to 1.75 is nothing but 0.4332 and between 0.75 to 0 to 0.75 is 0.2734 and the difference of these two is nothing but 1.95. Actually you need to find out the number of workers between these two. So to find out the number of workers, what are the total workers in the given company given as among 4,000 workers, you need to find out the number of workers between 600 and 900, which becomes nothing but you need to multiply the total number of workers into obtained probability, which is around 958.8, which is nothing but 959 approximately. Means there are 959 workers whose salaries are between 600 and 900. So to find out the number of workers, first you calculate the probability as usual, then you multiply that with the total workers. Okay, thank you.